So here there's a ground. The liquid what will happen will emerge with a speed v. This is also called as a jet. Okay, this is called a velocity of efflux. The hole is made at a depth h. What is velocity of efflux? That v is called as velocity of efflux here. So here air is present. Here air is present. Okay, how to calculate velocity of efflux? What do you mean by velocity of efflux? The moment you open hole, okay, that one, the first layer of liquid will emerge with a certain speed. So the velocity of the first layer of a liquid that is emerging from hole is called as velocity of efflux. Finish or nothing, don't bother anything that one. So what do you mean by velocity of efflux? The first layer of liquid that emerges from the hole. The velocity of first layer. The velocity of first layer of liquid that emerges from the hole is called as velocity of efflux here. How to calculate that V? And afterwards range, what is the time taken? All the quantities I want to find out that one. So let me call this a range. Now I'll apply the Bernoulli's theorem. So here I'm asking you to assume a tube. Actually, the tube should be here only to make you understand. So let this be the point 2. What is the point 2 on the wall? And the point 1 is just inside. Let me begin with the concept. Yeah. So this is the point 2. This is a point 1. So, here let's make it a little bit big. I'm just magnifying that one. So this is the point 2. This is a point 1. Here, what is the state of liquid at rest? No? And this liquid is in motion and it is exposed to air. Will I agree? And this is that hole, small hole. A small hole is made here. What is 2 hole is made? Everyone is able to understand this one? Now let's apply Bernoulli's theorem between 1 and 2. What is the state of this entire liquid at rest only? So let's apply Bernoulli's theorem between 1 and 2. What is the pressure at 1? P1. 1 and 2 are at same potential, same level. Okay, time being, let me write U1 plus K1 equal to P2 plus U2 plus K2. What is the pressure at 1? P0 plus rho GH. You move inside the liquid. P0 plus rho GH plus U. What is the state of liquid at 1? At rest, 0. Kanji. Pressure at 2. 2 is exposed to air, no? Will I agree? Everywhere here is air. So the moment you open hole, what happened? The layer of liquid which is at hole will be exposed to atmosphere. So therefore the pressure at 2 should be P0 U, and it will rush with a velocity V. So kanji per unit volume rho V square by 2. So everything will get cancel out. So V is equal to root of 2GH. So it is as if this layer of liquid will be falling from a height h. So is it really it has fallen from height h? No. The moment you open up the hole, the liquid at 2 open will rush with a speed root of 2gh as if it is descending from a height h. But actually what happened? It has not moved, just it was here. The moment you open hole, it will emerge with a speed v. This is the velocity of the first layer of liquid that we call velocity of efflux here. Okay, don't just fight with the word efflux. If you're finding very difficult to digest, no, just call the velocity of first layer of liquid the moment when you open hole. It is equal to how much? Root of 2gh. What will happen to this layer? It will traverse in air and it will strike the ground. So continuously, if the hole is kept open, continuously open, the liquid will come out, no, and we'll call that as a jet. See, these are very simple things, sir. Like, why do it will move? I think like you just take polythene bag, fill up water, take some needle, something, prick some hole, and then what will happen? The water starts coming out from here like this, no, and the continuous layer of water flowing, we call that as a jet. Is it okay? So rather than saying like a, like continuous flow, volume of flow of water is there, no, we'll just call, we'll give a name, jet, that one. So now what is the range of jet? After what time the jet, what happened? What is the time taken by the jet to move from the hole to the ground? So we'll take this horizontal distance, we'll call this range. So what is the height descended by the jet? Capital H minus small h, and it was having only horizontal velocity. So what is the height descended? This one. So therefore next equation, h minus h is equal to g t square by 2. T equal to 0, it is here. After some time, it will come and strike here. So what is t is equal to now? 2h minus h by g. Then what is the range, horizontal range of the jet? Velocity of efflux into t. What is the velocity of efflux? 2gh. So g get cancelled. So this will be root of 4. This is the expression for the range. Okay, now, so this, what you can do is 4 okay, let's differentiate. Anything we'll get, we'll see. Dr by dh is equal to 1 by 2 4h minus 4 into will I agree this? This should be. Okay, now if I further simplify, 4h minus 8h by root of, so let me equate this 4. H is equal to h by 2. This value of small h, I'll substitute here this one. Then I'll get the range. So the maximum range will be 4. H is how much? H by 2. H by 2. So finally, what is the maximum range? Will become h. So what is the maximum possible range of the jet? Will be equal to the height of the liquid in the container, and where that hole should be made at a depth h by 2. Then the range will be maximum. Are you able to get this one? So that will be the maximum range of the jet here. Okay, now let's explore this. So let's make a hole at various points. All of you, I think just you see once. From where we have started with Bernoulli's theorem. We have started with Bernoulli's theorem. So there we have put expression for what I got for maximum range of the jet on the horizontal surface equal to capital H, and where that hole should be made exactly at half of the height of the liquid column. So 10 meter is there. You make hole exactly at 5 meter, then you get the maximum range.